Britain once put an aircraft-like turbine inside a steam locomotive, sent it to work on the West Coast main line, and discovered something inconvenient. The extraordinary machine was not a failure. It worked for years. Yet only one was built. Its turbine was eventually removed, its identity changed, and the locomotive disappeared before preservation could save it. Why did a promising experiment lead nowhere? The answer begins with a familiar problem hiding beneath every conventional steam express. Pistons delivered power in alternating thrusts, and those thrusts passed through heavy rods to the driving wheels. Counterweights could balance the rotating masses, but not every reciprocating force. At speed, the remaining vertical forces could pound the track in a phenomenon railway engineers knew as hammer blow. A turbine offered a radically smoother proposition. Steam would spin rows of blades in one direction, producing continuous rotation rather than repeated blows from pistons changing direction several times each second. That did not make a turbine automatically suitable for a locomotive. Turbines preferred sustained high rotational speeds. Railway driving wheels had to start from rest, accelerate heavy trains, and operate across a wide speed range. Stationary power stations could connect turbines to generators under controlled conditions. A locomotive had to carry its boiler, transmission, and reversing arrangements within the British loading gauge, then survive vibration, coal dust, and daily railway handling. The London, Midland, and Scottish Railway nevertheless had reason to investigate. Swedish engineer Fredrik Lundström had developed successful turbine locomotives, and William Stanier examined the possibilities after becoming the LMS chief mechanical engineer. The railway already possessed a suitable foundation. Stanier's Princess Royal Pacifics were large express locomotives with a 4-6-2 wheel arrangement, substantial boilers, and the capacity required for demanding West Coast services. The third intended member of that family became something different. Constructed at Crew Works in 1935 and numbered 6202, it retained Princess Royal ancestry while exchanging the normal driving cylinders for turbine machinery. From a distance, 6202 could still resemble a conventional Stanier Pacific. It had a leading four-wheel bogie, 3 large coupled driving axles, a 2-wheel trailing truck, and a separate tender. Closer inspection broke the illusion. Long turbine casings and enclosed gearing occupied the space where outside cylinders and conspicuous valve gear would normally dominate. The driving wheels lacked the familiar external coupling rods. The locomotive was not officially named Turbomotive during its original career, although the nickname became inseparable from it. Its identity remained the plain number 6202, later expanded to 46202 under British Railways. Its principal forward turbine was a multi-stage reaction design. Steam expanded progressively through rows of fixed and moving blades, turning the turbine shaft at far greater speed than the locomotive's driving wheels. Reduction gearing translated that high-speed rotation into useful wheel speed. A flexible drive helped transmit power to the coupled axles while allowing the movement demanded by suspension and track irregularities. This arrangement attacked hammer blow at its source. Without large driving pistons, connecting rods, and external coupling rods repeatedly accelerating and stopping, the turbine produced a much smoother turning force. The visual calm was striking. A large steam express could move without the thrashing outside motion that appeared inseparable from locomotive power. Beneath the boiler, rotation replaced reciprocation. But a turbine optimized for forward express running created an immediate operational complication. It could not simply reverse its direction as conveniently as conventional locomotive valve gear. Number 6202 therefore carried a much smaller reverse turbine. It was intended chiefly for light engine movements, not for hauling a heavy train backwards over any meaningful distance. The locomotive consequently needed to face the correct direction for serious work. Turntables remained operational important, and the small reverse turbine exposed how an elegant high-speed solution could become awkward around stations and depots. Starting also required careful engineering. A turbine's efficiency improves when it is rotating rapidly, whereas a locomotive demands its greatest tractive effort while moving slowly from rest. The LMS solution used stage steam admission so that additional parts of the turbine could receive steam as demand increased. It sought usable control across the railway speed range instead of one narrow optimum. If this engineering investigation is the kind of railway history you value, give the film a like and subscribe. The most revealing locomotives are often the ones that never became a class. The railway did not merely admire the machine and publish optimistic publicity. It tested 6202 against conventional Princess Royal Pacifics under instrumented conditions. Science Museum Group catalog records preserve the existence and purpose of LMS comparative reports from 1936. Turbomotive was tested against standard reciprocating Pacifics, including numbers 6210 and 6212. Those reports matter because they correct an easy modern assumption. An unusual locomotive that remained unique is often described backwards, as though uniqueness itself proves technical failure. Number 6202 entered real express service. It worked the railway for years rather than completing a brief sequence of demonstrations before being quietly stored. At higher outputs, the turbine could exploit the conditions that suited it: sustained rotation, continuous steam flow, and express running. Its smooth power delivery reduced the violent dynamic effects associated with conventional motion. Crews encountered a locomotive with different controls and behavior, but not an incomprehensible laboratory device. It operated within the broader coal, water, boiler, and tender system already understood by the LMS. That compatibility was one of its strengths. Turbomotive tested a new method of converting steam into wheel rotation without requiring an entirely new national fueling network. It was still a steam locomotive in every upstream sense. Coal released heat in the firebox. The boiler produced steam. The turbine merely replaced the piston engine as the final power converter. This distinction explains both its ingenuity and its limitation. The experiment could reduce hammer blow and simplify some moving parts, but it could not eliminate firing, boiler maintenance, water consumption, or the labor structure of steam operation. Its performance record nevertheless became substantial. Specialist historical syntheses credit the turbine locomotive with more than 300,000 miles before its turbine career ended, although published totals vary with the dates and mileage categories counted. Wartime service was especially revealing. A fragile publicity machine might have disappeared when maintenance resources tightened and traffic demands intensified. Number 6202 instead continued working, although unique components inevitably complicated repair. Failures did occur. The flexible transmission and reverse machinery were not immortal, and the one-off design could not draw upon a fleet-wide pool of identical replacement assemblies. That is different from saying the turbine principle failed. Conventional locomotives also suffered defects in workshop visits. Their advantage was that railways possessed established parts, skills, and repair routines for large classes. Here the story turns from performance to replication. If 6202 was smooth, capable, and sufficiently reliable for prolonged service, why did the LMS not order turbine Pacifics by the dozen? The locomotive offered improvement in a problem that railway engineers understood, but improvement had to justify unfamiliar manufacturing, specialized maintenance, and operational restrictions. A successful machine was not automatically a successful fleet proposition. Conventional Stanier Pacific development also continued. The Princess Coronation class delivered enormous express capability, using improved but familiar piston machinery, supported by workshops already organized around cylinders, valves, and rods. Turbomotive therefore faced a moving comparison. It did not need merely to work. It needed to outperform increasingly refined conventional steam locomotives by enough to repay the cost of being different. The turbine's smoothness had real value, particularly for the track. Yet railways could manage hammer blow through wheel balance, axle load limits, track standards, and better conventional design without adopting an entirely unique transmission. The small reverse turbine remained another compromise. Mainline locomotives did not normally haul express trains tender first, but railway operation demanded more than ideal forward runs between major terminals. Then, war and post-war austerity changed the economic setting. Experimental continuity became harder when workshops were managing worn fleets, restricted materials, and an enormous maintenance backlog. In 1949, a turbine failure removed 46202 from service. Repair was possible in principle, but restoring bespoke turbine machinery was no longer the only option facing British railways. By then, the locomotive was 14 years old. Nationalization had absorbed the LMS, and conventional Pacific components offered a cheaper route back to useful traffic. The decision was made to rebuild it with piston cylinders. This is the episode's central contradiction. Turbomotive was not converted because years of service had proved that it could not work. It was converted because its unique machinery was expensive to sustain inside a system favoring standard repair. At Crewe, the turbine apparatus disappeared. 4 conventional cylinders and associated motion transformed the power unit, drawing on Princess Coronation practice while retaining much of the original Princess Royal-derived locomotive. The result was not simply an ordinary production Princess Royal. Its history remained embedded in the frames and in details of the conversion, but its defining turbine identity had been removed. In 1952, the rebuilt locomotive emerged in British Railways lined green as number 46202. It received the name Princess Anne, honoring the young daughter of the future Queen Elizabeth II. A machine once distinguished by the absence of outside driving cylinders now displayed conventional motion. The turbine experiment had become a unique 4-cylinder Pacific rather than a member of a standard class. That rebuilt career lasted only weeks. On October 8, 1952, Princess Anne was one of the locomotives involved in the catastrophic collision at Harrow and Wealdstone. An overnight express struck a local passenger train at the station. Moments later, the northbound express, headed by Princess Anne and Jubilee number 45637 Windward Islands, entered the wreckage. The disaster killed 112 people and injured hundreds. The human loss must not be reduced to a dramatic ending for a locomotive story. 46202 was one damaged object within a national tragedy. Princess Anne was assessed as uneconomic to repair and was scrapped. Thus, the physical line back to the 1935 turbine experiment vanished only months after its conversion. No museum could later reverse the rebuild, inspect the original turbine, or demonstrate its silent-looking drive. Photographs, engineering drawings, test reports, and written testimony became the surviving machine. The National Railway Museum's drawing catalog still lists casing details specifically for number 6202, together with Princess Royal boiler, clothing, and later conversion material. These records preserve the locomotive as an engineered system rather than a legend. The Science Museum Group's LMS test report records are equally important. They show that direct comparisons with reciprocating Pacifics formed part of the program, anchoring the story in measured railway investigation. What then did Turbomotive prove? First, a mechanically driven steam turbine could perform sustained British mainline work rather than remaining a theoretical curiosity. Second, continuous rotary power could reduce hammer blow and remove much of the conspicuous reciprocating machinery of a conventional express locomotive. Third, technical success did not solve the economics of uniqueness. A railway buys availability, repairability, and system compatibility as surely as it buys horsepower and efficiency. Turbomotive's weakest feature was therefore not necessarily the forward turbine, it was the absence of a fleet around it. No production run spreading knowledge, parts, and development cost across many locomotives. Its timing also mattered. Had turbine development continued, engineers might have refined reversing, transmission, and maintenance. But the post-war railway was approaching diesel and electric traction, technologies that removed the steam boiler as well as the pistons. A turbine steam fleet would still have required coal, water, firemen, boiler washouts, and heavy steam infrastructure. It improved the final stage of a system whose entire future was becoming uncertain. That makes 6202 neither a suppressed revolution nor an embarrassing dead end. It was a credible solution to particular steam locomotive problems, tested seriously enough to reveal where engineering merit stopped and railway economics began. Its later destruction intensified the mystery because no original survives for enthusiasts to hear, measure, or compare. The smooth-running express exists now through evidence and reconstruction of principle rather than preserved motion. For the next investigation, should this channel examine another successful one-off, a prototype that genuinely failed, or an extinct production class? Put your choice in the comments and subscribe to follow the evidence rather than the legend. Number 6202's most important lesson is not that turbines could never power locomotives. It is that one turbine locomotive did power British expresses for years and still could not make uniqueness economical. The experiment succeeded narrowly, lost strategically, and vanished physically. Beneath an apparently familiar Stanier boiler, Turbomotive briefly showed what a British steam express could become when its pistons disappeared.